The following is a defense of my Capstone proposal on mitigating the harmful effects of agriculture in the U.S. The research questions I am looking to answer include: can agricultural practices be adapted to minimize harm to ecosystems and wildlife? What are best practices for reducing agricultural non-point source pollution? What sustainable agricultural practices and policies are most likely to succeed in the U.S.? The first research question that I will explore: can agricultural practices be adapted to minimize harm to ecosystems and wildlife? Should be researched due to deforestation, habitat loss, habitat degradation, loss of soil fertility, and species loss that occur as a result of agricultural practices. The most direct example are habitats being converted to agricultural cropland. It is estimated that 39% of habitats have been replaced by urban and agricultural settlements, and another 37% of habitats have been degraded and fragmented. In the U.S. alone, 92% of species are affected by habitat destruction. The future of the environmental impact from agriculture will depend on regional policies, habitat type, and individual species characteristics. Some species will benefit from agricultural development as habitats change, depending on their ability to adapt and competition reduction as a result of species decline. In Iowa, agricultural production is expected to reduce reptile and bird habitat by 30 to 37%, while habitats suitable for mammals are expected to increase by 15%. In Oregon, where policies are focused on improving water quality, and in the Willamette Basin, habitats for reptiles are expected to increase. The second research question is: what are best practices for reducing non-point source pollution? Fertilizers, pesticides, and other chemicals used in agricultural production do not remain on farms. Excessive nutrients and pesticides are washed into surrounding waterways and negatively affect surrounding ecosystems, creating some habitats that are uninhabitable to animal life. Non-point source pollution is one of the most common sources of pollution for U.S. streams and lakes. Over-application of fertilizers like nitrogen and phosphorus lead to eutrophication and hypoxic conditions. Excess nutrients lead to an overabundance of plant life and low oxygen conditions that kill aquatic animals. Collecting runoff along the Mississippi River, the Gulf of Mexico has seen nitrogen levels triple since the 1970s and is home to a hypoxic zone, also known as a dead zone, due to low oxygen conditions that can kill fish. The third research question: what sustainable agricultural practices and policies are most likely to succeed in the U.S.? It is important to ensure that new policy implementation actually has a chance to succeed. There are many regional factors that influence the likelihood of success for environmental policies, such as cultural differences, different values, and economic and technological differences. For example, research in Brazil has shown that crop productivity can be increased to support an increasing population and increased meat consumption without actually expanding agricultural land. Improved practices and government investment can increase agricultural productivity on the land currently in use without converting additional natural habitats. In England and Wales, a practice known as integrated farm management allows for continued agricultural growth while considering the environmental impact of practices. Diversified farming systems is a practice that is used in rangelands that, if expanded, can increase biodiversity, improve riparian buffers, better support pollinators, and generate financial gain for the range owner. Wetland restoration of unused pastures can be used as a pollutant and nitrogen filter, along with creating habitats for wildlife. Examples of this include the North River Farms in Carteret County, North Carolina, and Keller Farm Wetland Mitigation Bank in Redmond, Washington. In order to increase the potential for success, factors that influence adoption of policies, like farmer age, education, available finances, and subsidies, will be researched to maximize the likelihood of sustainable practices being adopted. The following will be my thesis statement. Analyzing successful sustainable practices can reveal best practices to mitigate further ecological harm and assist ecosystems and wildlife in recovery. By comparing agricultural case studies and soil and water quality data, the negative environmental impact of the U.S. agricultural industry can be reduced. My hypothesis is implementation of sustainable practices in the United States agricultural industry can lead to healthier ecosystems. The current status of agricultural pollution in the U.S. is being addressed by the EPA, U.S. Fish and Wildlife, USDA, which has programs such as the National Water Quality Initiative and Natural Resource Conservation Service. Analyzing the successes and failures of programs implemented by these institutions will further contribute to identification of best practices and reducing agricultural pollution. As previously described, waterways experience impaired conditions as a result of fertilizers, pesticides, and erosion from agricultural practices that are not contained to croplands. Expanding agricultural areas lead to habitat loss through the conversion of natural habitats to cropland, and also degrade surrounding habitats through pollution and habitat fragmentation. These combined negative effects create compounding pressures on ecosystems and wildlife, and globally, agriculture may be the main cause of species extinction. The data for this research will come from the American Public University System Library, using the latest peer-reviewed scholarly journals and case studies from these journals. EPA and USDA water and soil quality data will be used along with data from the Environmental Quality Incentives Program, which contains a list of sustainable practices currently being put in place in the U.S. U.S. Fish and Wildlife Service land management plans will also be used to identify restoration projects. Peer-reviewed case studies will be researched for successful and failed practices in reducing nitrogen, pollutants, and erosion. This will be used to develop best practices and to identify what factors lead to success or failure, to identify which practices can be adapted or implemented in new areas. Types of factors that will be researched include landscape, pollutant type, and technological and economic limitations. For example, are local government programs available that provide funding to farmers looking to restore unused agricultural land to natural habitats? EPA, USDA, and U.S. Fish and Wildlife Service data on soil and water and wildlife counts will be used to identify improvements over time in areas that have implemented recovery plans or mitigation plans. This data can also be used to identify areas that have the greatest need for mitigation efforts by identifying the areas with the greatest soil and water quality impairment. This research is needed to contribute to the literature of what practices need to be implemented in the U.S. to reduce the harmful effects of agricultural pollution. By identifying areas that require mitigation efforts and what practices are most likely to succeed, critical natural habitats can be conserved or restored, pollutants can be reduced or contained, and crop productivity can be increased without the need for expanding agricultural cropland. This research will also identify the practices and factors that increase the likelihood of success when implementing sustainable practices. By researching factors that influence the odds of environmentally friendly practices succeeding prior to ever implementing policies and practices, efficacy can be improved and costs can be saved. Perhaps more importantly, the odds of improving ecosystems and conditions for wildlife will also increase.